Hello. Today in class we're going to be doing some stuff on quadratic formula, but before we do that, I want to do kind of a preface on radicals and simplifying square roots and things like that, because that is part of the quadratic formula, but for some of you it's been a while. So just simplifying square roots is something you're going to have to do in the middle of it, towards the end. And sometimes you simplify, sometimes you don't, but when it does simplify, it goes something like this. First of all, this is a regular kind of square root where you can simplify it. The way you do that is through a number tree. You are just looking for any two numbers that would multiply to 20. So like you could do 2 and 10, you could do 5 and 4, either of those things. We'll just do 2 and 10. And then you would just do it again. Like 2 can't split up, but 10 is the same thing as 2 times 5. And you would just split this up until all of the numbers just can't be split anymore. And you're going to look for 2 of a kind. So here there are 2 2s and then a leftover 5. So whatever it is that you circle, you can write down, and then whatever is left over stays inside the radical. So this would be 2 times the square root of 5 for the final answer. Just to show you what would happen if maybe it was square root of -3. This is having to deal with square root of negative numbers. Normally, you would just go through and say this is no solution if you were trying to find zeros, like if you actually had to graph them or something. It's one of those things where it wouldn't actually touch the x-axis. But when you do quadratic formula, sometimes you do want imaginary solutions. So all you do is you make this positive and you put an I out in front. So your final answer would just be I times the square root of 3. Sometimes when you do square roots, it'll literally just be a number. Like if it says the square root of 25, in the actual quadratic formula it'll be plus or minus, but you can actually do this. The square root of 25 is 5, so you would just put a 5, and there'd be no radical anymore. So that also happens. Sometimes there's a combination of these. You can have the square root of -9. In which case, once you get used to this, you can probably just immediately go to, oh yeah, that's 3i. But it's just these two concepts put together. If you have the square root of -9, you can make that positive and put this out front. And then you have I times the square root of 9. But the square root of 9 is 3. So you would just get 3i. Also mixing like this concept with a negative, you could have the square root of -50, in which case you would split this up. We'll do 10 and 5, and then this would go into 5 and 2. So you would once again have a pair of 5s and a leftover 2. So you would have the 5 that you can circle and the leftover 2. But because there was this negative sign in there, you would have to sneak an I in front, because the I is always going to be outside the radical. It will never be inside here. So your final answer would be 5i root 2. Other things that can happen, let's pretend that we were doing the quadratic formula and we ended up with something like this. This can be simplified in 2 ways, and I don't mean like you have options. There's 2 things you have to do to simplify this. The first is to simplify the square root of 72, and then you're going to see what happens afterwards. So like over here in scratch work, if this is like our actual starting problem, we would have to do a number tree with 72, which 2 goes into it, and then you figured out how many times 2 goes into 72. So either calculator or do it in your head or by hand, but basically 2 goes into 7 3 times, and that leaves 1 left over. So then 2 goes into 12 6 times, and you'd get that. And you can keep going. This is 6 times 6. Then a 3 and a 2, a 3 and a 2. Now you have a pair of 2s here and a pair of 3s here, and that's it. The 6 got split up, so you don't need to do anything with them. So you have a 2 and a 3 both circled, and then this leftover 2. These do get multiplied, so your final answer would be 6 root 2 for this part. So 6 root 2 is what this becomes. 3 plus 6 square roots of 2 all over 3. And what you do next is something that I like to call the heart technique. I love it. Basically, whenever you have two things being added on top divided by a single thing, you have to split them up. You do that using this kind of heart shape, yay. And you just divide those two parts. So 3 divided by 3 is 1. And then you have a plus or minus. And then the 6 over 3 is equal to 2. So you would have 2 root 2. And that's how it would fully simplify. These divide to get 1. These divide to get 2. This is a whole number. Whole numbers can only reduce whole numbers. Please keep that in mind. Whole numbers can only reduce whole numbers. You're never going to take this number and divide it by 3. Like if you tried to do that up here, because 3 does go into 72, if you divided them up there, you'd get something completely different. So you do have to simplify first, and then whole numbers can simplify. But this is not a whole number, this is a radical. Radicals do not simplify whole numbers. And you'd get that. Just to show you 2 more examples, just to make sure you can get it. If this ain't making sense or you want to look at it again, remember you can always pause a video to kind of look at it. Or you can rewind the video to go over it. If you feel like I'm going too fast, this is a video. You can pause it, you can rewind it, whatever helps. So, 2 more examples. 5 plus or minus square root of 50 over 10. You would once again have to take 50 and reduce it. This time we'll do 25 and 2, which is then 5 and 5. So you got a pair of 5s and a leftover 2. So 5 root 2. Like I said, pause it if you need to slow down, but I'm just going to keep going. This will be 5 plus or minus 5 root 2 over 10. You can then use the heart technique to reduce it. 5 and 10. 5 goes into 5 once, and 5 goes into 10 twice. So this reduces to a 1 and a 2. Same thing happens up here. This 5 and the 10, both of these go into 10, or 10 go into both of them. I don't know. It's just that they have a common number. All 3 of these terms have a 5 that goes into them. So you can divide all 3 of them by 5. When you do that, this just becomes a 1 root 2, or just a root 2. And that would be your final answer right there. All right. Just keep in mind, if this was like 5 plus or minus the square root of 3 root 2 over 10, just pretend for a second it is. If we had this, then yeah, the 5 and the 10 would reduce, but it's impossible for the 3 to reduce. For that reason, that would just be your final answer. You can't simplify this because nothing goes into 5 and 3 and 10. It has to go into all 3 whole numbers. There you go. Okay, last example I want to do is something that's, I don't know, it confuses some people more than it should. It's what happens when you get a whole number. So 2 plus or minus the square root of 36 over 4. This messes people up. What's the square root of 36? It is 6, which means you are supposed to write down 2 plus or minus 6. I don't know why people want to keep the radical, but sometimes they do. Square root of 36 is 6. End of story. Done. Boom. Like that. However, this is not your answer. Before, we can't combine a 1 and a 2 root 2. We could not combine a 1 and a root 2. But 2 and 6? Yeah, you can add 2 and 6. So you're going to do those two things. It does say plus and minus in the quadratic formula, so you would have to do 2 plus 6 over 4 and 2 minus 6 over 4. Here you would get 8 over 4, which is 2. And here you would get negative 4 over 4, which is negative 1. So you do get whole numbers sometimes. Usually, well, not usually, all the time, if these actually turn out to be whole numbers or fractions or integers, whatever, that means the original quadratic was actually factorable. But it doesn't mean you did it wrong, it just means it would have been easier to probably factor it. Well, anyways, you guys are going to do quadratic formula now. Hopefully this was useful to you. Have a good one.